Hello, thanks for clicking. Welcome to another Calculus 2 production. Today we're going to be talking about absolute and conditional convergence. Okay, so as if life is not difficult enough, learning all of these series tests to determine whether or not a series converges or diverges, now we throw at you the fact that there are actually two different types of convergence that you can talk about. Okay, so let's get started and see how both of these types of convergence play into what we already know about our series tests and convergence and divergence. Okay, so first things first, a series that converges is considered to be absolutely convergent if the absolute value of the nth term of that series converges. Okay, so again, think about that. A series that converges is considered to be absolutely convergent if the absolute value of the nth term converges. Absolutely convergent, absolute value of the nth term converges. See what we did there? Hopefully. Okay, so first things first. I want to know if this series, the sum from n equals 1 to infinity of 1 over n, absolutely converges. Well, I would say the first thing I can do is take the absolute value of it, but it doesn't do anything when I take the absolute value out of it. It's already positive. So the question at the end of the day is, does this series converge? Well, no. Right? This diverges. This series is the harmonic series. Okay, and p is less than or equal to 1. It's a p series, right? Well, p is equal to 1 on this, right? P is equal to 1. It's the harmonic series. And it's a p series, p less than or equal to 1. So it diverges. If it diverges, it can't be absolutely convergent. Okay? All right. So that's it for that one. So we're going somewhere with this. Let's take a look at the next slide and see how it's going to relate. So next, I want to know if this series, negative 1 to the n over n, converges. It's very similar to the series on the last slide, except now I tossed in this negative 1 to the n power, which makes this series alternating, right? So that's negative. If I plug in 2, it's going to be positive. Plug in 3, it's negative again. Okay, now it's an alternating series. But if it's an alternating series, then I can use the alternating series test to determine whether it converges or diverges. So the alternating series test says the limit as n goes to infinity of 1 over n without the alternating part has to be 0. And sure enough, that is 0. And then this has to be non-increasing, right? A sub n plus 1 has to be less than or equal to a sub n. So 1 over n plus 1 has to be less than or equal to 1 over n. Or that would mean that n has to be less than or equal to n plus 1, which it certainly is. Or I could solve it. 1 is less than or greater than or equal to 0. Okay, that's true also. So this converges by the alternating series test. So now, here's what I have. The previous slide shows me that 1 over n diverges. But the sum of negative 1 to the n over n converges. So that brings up our second type of convergence. A series is conditionally convergent if the sum from n equals 1 to infinity of a sub n converges, but the absolute value diverges. So that's exactly what we just had a moment ago. This sum from 1 over n, right, the absolute value of it, this diverged. But this sum converged. So we would say the sum from negative 1 to the n over n conditionally converges. Okay? Now, the easiest way I think to understand this is this series converges under the condition that it alternates, right? When I tossed in the alternating part, it made it converge. But without the alternating part, it diverged. Okay? So it's not absolutely convergent. It needs the alternating part to make it converge. Since it needs the alternating part, then it converges conditionally under the condition that it alternates. Okay? That's how the two types of convergence work. All right, so now let's see how we can work these to figure out how the whole thing, to get our best strategy going for finishing these as quickly as possible. I want to decide if this series converges absolutely, conditionally, or if it diverges. So it's the sum from n equals 1 to infinity, negative 1 to the n over n cubed. The first thing that you should do is take the absolute value of this and see if that converges. So that would be the sum of 1 over n cubed, right? That's going to be a positive no matter what. So the question is, does this converge? Well, this is a p series, right? P is greater than 1. So yeah, this converges. Since this converges in the absolute value, then this series is absolutely convergent. It converges in the absolute value. So I'm done. Once you show that something's absolutely convergent, then it's convergent. Okay? And then we don't have to say any more. All right? Okay, let's try this one. Same thing. So again, the first thing we're going to do is we're going to check to see if this is absolutely convergent. To do that, we're going to take the absolute value of it. That's going to be the sum, negative 1 to the n. Oh, sorry. It's going to be the sum of 1 over radical n. So that would be the sum of 1 over n to the 1/2 power. Okay, this is a p series. P is less than 1. So this, or equal to 1. So this diverges by the p series test. So it's not absolutely convergent. Now the question is it convergent under the condition that it alternates? Well, let's see. To figure out if this converges under the condition that it alternates, I need to use the alternating series test. So the alternating series test says the limit as n goes to infinity of 1 over square root n. 1 over the square root of infinity. That's 1 over something really big. That goes to 0 still, so that works. And then a sub n plus 1 has to be less than or equal to a sub n. So 1 over the square root of n plus 1 has to be less than or equal to 1 over the square root of n. So the square root of n would have to be less than or equal to 1 over the square root of n plus 1. But again, n is positive. So if n is positive, well, the next square root, 1 greater than, will be bigger than the one before it. So yes, that is in fact true. So this series is conditionally convergent. Okay, it converges under the condition that it alternates. It passes the alternating series test. So this converges by the alternating series test here. So then this is conditionally convergent. Okay, and that's how this works. All right, if the series diverges, okay, let's say the series does not absolutely converge, and then you try to see if it conditionally converges, and it doesn't do that either, then the series would diverge. Okay, if it doesn't fit either of the two convergences, then the series diverges. And that's it. That's the difference between absolute and conditional convergence. As always, thanks for clicking.